Good morning. We are now on lesson 4 of our set theory, and these are the remaining set operations: the complement of a set and the set difference, or the relative complement of a set. Today's objectives are to describe and define the complement of a set and the difference of sets, find the complement of a given set and the set difference, and use Venn diagrams to represent the complement of a set and the difference of sets. Now let us describe the complement of a set. So the complement of a set A, written as A prime, it is the set of all elements found in the universal set U but are not found in set A. Writing the notation, we have A prime, or the complement of A, contains X such that X is an element of U and X is not an element of A. And the cardinality is the number of elements in the complement of A is equal to the number of elements in U minus the number of elements in A. Using Venn diagram to show the complement of a set. So we have here the universal set, the rectangle, and we have set A, and the shaded portion is the elements not found in A. So they are the complement of A, or the elements outside A. Let us have an example number 1. So if we have universal set containing numbers from 0 to 9, and we have set A containing 0, 2, 4, 6, and 8. So the elements of the complement of A, they are the elements from U but are not found in A. So we have here 0, 2, 4, 6, 8. And the complement of A is 1, 3, 5, 7, 9 because they are the elements not found in A but are still in U. We can clearly see our set notation using Venn diagram. So this is our universal set. It contains all the elements from U to 9 or O or 0 to 9 and A contains 0, 2, 4, 6, and 8. So the elements outside A, or the complement of A, are 1, 3, 5, 7, and 9. Let's have another example. We have here universal set containing 1, 2, 3, 4, and 5, and we have two subsets. We have A having 2 and 4, and B has an element 1 and 5. So we can say that the complement of A is 1, 3, and 5. Since 2 and 4 is inside A, so we can find 1, 3, and 5 outside A. Let's see the complement of B. So if B is 1 and 5, so the elements outside B but is still inside our U is or are 2, 3, and 4. So therefore, if we have to get the union of the complement of A and the complement of B, combining all their elements, we have 1, 2, 3, 4, and 5. So we can say that the union of the complements of A and B is also equal to universal set. So showing those sets using Venn diagram, we have our universal set here. It contains 1, 2, 3, and 4, 5. And set A contains 2 and 4. And we have set B containing 1 and 5. So as you can see, we have a disjoint set because there are no elements in common in A and B. So we can say that complement of A are the elements outside A. So what are those elements? So 1, 5, and 3. And the complement of B are the elements outside B. So those are 2, 3, and 4. Now let's have example 3 with our universal set containing 1, 2, 3, 4, 5, 6, 7, and 8. And we have set A contains 1, 2, 3, and 4. Set B contains 3, 4, 7, and 8. Then we have here the complement of A, or the elements, or all the elements not found in A are 5, 6, 7, and 8. And the B complement are the elements not found in B. So those elements are 1, 2, 5, and 6. So therefore, if we are to get the intersection of those two sets, or the intersection of the complement of A and the complement of B, we are now to look at these notations. So we have to find their common element. So we have here common element 5. We have 5 and the number 6. So we only have two common elements in the intersection of the complement of A and the complement of B. So can you represent these sets using Venn diagram? Now let us have our example number 4. We have the universal set U containing 1, 3, 5, 7, and 9. Set A has 5, 7, and 9. B have the elements 1, 5, 7, and 9. So we have to get the intersection of A and B. So we have to look here for their common elements. So we can see that they have 5, 7, and 9 as their common elements. So therefore, we can say that the complement of the intersection of A and B is 1 and 3. How's that? We are to look at this notation and our universal set. Since these are the elements inside the intersection, so these must be the elements outside the intersection but are still found in U. Can you please show the Venn diagram representing these sets? Now, do you have any questions about this lesson? If there are no any more questions, please do this activity.